Hi everybody, we are back and we are going to do our ANOVA analysis, not on Elden Ring, instead on some NHL goals that are scored. So we're going to be focusing on Alex Ovechkin, 10% significance level, whether the location and outcome of the game has a statistically significant effect on the number of goals Ovechkin scores. We're going to characterize the size of each effect of the variable and run the appropriate post hoc test to determine the statistical significance between experimental conditions within each variables. We're going to determine the optimal set of conditions to maximize the goal output. So we're going to create an ANOVA. Summarize test results, include plots, not for the deaths, but for the number of goal scores for the specific variables. So we are going to run effectively a two-way ANOVA. So let's go ahead and let's get to our, we're going to read in our packages. We are going to set this as our working directory. Then we're going to read in, set this as a working directory. We're going to read in our data, which is games goals. And we can see we have player, we have season, game number, et cetera, age. And really the key things that we're looking at here is location, outcome of the game, and then the number of goals scored. So this is a variable, and then we have our numeric, which is goals. And we're only going to look at this for Alex Ovechkin. So we need to filter based on Alex Ovechkin. We need to select location, outcome, goals. And we are going to set this data set. We're going to set the location as a factor. We're going to set the outcome as a factor. And we're going to create our goals as our numeric. And we want to do this, and we have to do this to make sure this is excellent, because you see here we're getting numerical data only for the goals, and then these are just basically the conditions within each of these variables. So we're going to take our numeric and we're going to look at location, outcome, and outcome and location, and our data is going to be this OV data. So we're going to do that. We're going to look at our data set, and what we can see here, and we can double check this is great because we have conditions. So our degrees of freedom should be 3 here, excellent. And we see location is not statistically significant, but outcome is very statistically significant. However, what about the size of the effect? Size of the effect, interestingly, is basically super small or nothing for this, and kind of in the medium range for the outcome. And we can kind of look at this and see. And actually, we can look at this. So let's look at location, for example. So location is statistically insignificant. And we can see if we look at basically home or away, we can see this here, they are not statistically significant. However, if we look at the outcome, we see here that loss and loss over time are not statistically significant from our p-value here, 0.38, because we're doing a 0.1. So this is not statistically significant, neither is loss and shootout. Loss and win is very statistically significant. Not loss and not here and here, loss over time as well. There is statistical significance between loss over time and wins as well as this and this. So basically, all of these are the same: loss over time, loss, shootout, and they are all different from the win. So if I want to optimize my conditions for Alex Ovechkin to score goals, I want to win the game, and it doesn't matter whether I play home or away because those are both statistically the same. So that's essentially the statement that we would make here, and that's your ANOVA lab. So thank you very much. I'm looking forward to seeing your final projects, and I will see you next time. Thanks. Bye.